Here we're going to be learning about rational numbers. We're going to discuss a few properties of rational numbers, how to classify them, how to compare them, and ultimately how to order them. Now, a rational number is simply a fraction. We have 2 over 3. It consists of a numerator and a denominator that's separated by a division sign. Now, the first thing we want to do with a rational number is we want to classify it. Now, when I say classify it, it can be one of two things. We can have a proper fraction, or we can have an improper fraction. Now, how do we know if we have a proper fraction or an improper fraction? A proper fraction has a numerator that's smaller than the denominator, such as 2 over 3. And an improper fraction has a numerator that's greater than the denominator. 2/3 is an example of a proper fraction. 2 is less than 3. Another thing we want to do with a rational number is simplify it. We want to put each rational number in lowest terms. And when we find out if a rational number is in lowest terms is there a factor that we can divide evenly into 2 and will also divide evenly into 3? And the answer is no. 2 and 3 are both prime numbers and they're only divisible by 1 in itself. So 2 and 3, 2/3 is in simplest form. Let's do another example. Let's look at the fraction 2 over 4. Now, is this proper or improper? This is a proper fraction because the numerator is smaller than the denominator. Is it in lowest terms? Well, is there any number that we can divide evenly into 2 that will also divide evenly into 4? Well, the answer is yes. We can take 2. 2 will divide evenly into 2 one time. 2 will divide into 4 2 times. 1/2 is a fraction in lowest terms because you can't divide it evenly any further. It's the same value as 2 over 4, but we always want to leave a rational number in lowest terms. We never want to leave it as 2 over 4. Let's take the rational number 8 over 4. Now, proper or improper? Well, this is an improper fraction. The numerator is greater than the denominator. There's nothing wrong with that, it's just classified differently. So it's an improper fraction. Now, is it in lowest terms? Well, is there any number that we can divide evenly into 8 and also divide evenly into 4? Well, yes, we can take 4. 4 will go into 8 2 times, and 4 will go into 4 1 time. We can actually simplify this a little further and write it as 2. Any rational number that has a denominator of 1, we can also write as a whole number. And let's do one more example. Let's take the fraction 20 over 30. Now, is it proper or improper? Well, this is a proper fraction. The numerator is smaller than the denominator. Now, is it in lowest terms? Well, is there anything we can divide evenly into both the numerator and the denominator? And of course, we can take 10. 10 will divide into 20 2 times, and 10 will go into 30 3 times. 2/3, like we saw up here, is in lowest terms. But there's also a shortcut here that we can use. When we're dealing with numerators and denominators that are powers of 10, we can cancel the last zeros and keep the 2/3. Now, this is really helpful when we're dealing with very large numbers that have a lot of zeros. However many zeros are at the end of the denominator, that'll match up with the numbers at the end of the numerator, we can cancel them out. If this was 200 over 300, we could cancel these two. For example, if we had 20 over 400, we would only be able to cancel the last 2. So keep that in mind when we're dealing with larger numbers. Now, the next thing we want to do with rational numbers is we want to be able to compare them. Let's compare the numbers 10 over 12 and 3 over 4. Now, we can do this one of two ways, but we always want to have the same denominator for both fractions. It makes things much easier because we can just compare the numerators if they both have the same denominator. Whatever numerator is greater is larger fraction. So what we want to do is we want to transform one or both of these fractions to where they have the same denominator. Now, we only have to transform one of the fractions if one of the denominators will divide evenly into the other denominator. And here's the case. 4 will go into 12 evenly. So let's take 3 over 4 and transform it into a fraction that has 12 as the denominator. How do we get from 4 to 12? Well, we multiply by 3. 4 times 3 is 12. Whatever we do in the denominator, we must do in the numerator. See, we're actually multiplying by 3 over 3, or 1, and we're not actually changing the value, just the look. 3 times 3 is 9. So we can actually now easily compare 9 over 12 and 10 over 12. And we can see that 9 over 12 is smaller than 10 over 12 because 9 is smaller than 10. They both have the same numerator. So from that, we can conclude that 3 over 4 is smaller than 10 over 12. We're not actually ultimately comparing these two fractions. We're just transforming it so we can make it more easier to deal with. We're comparing these two fractions, and this is our answer right here. Let's do one more. Let's compare the fractions 3 over 5 and 5 over 7. Now we can't use the same trick that we did over here. 5 won't divide evenly into 7, and 7 won't divide evenly into 5. So what we're going to have to do here is transform both fractions into fractions with the same denominator. So what we're going to want to do is multiply these two denominators. 5 times 7 is 35. So we're going to want to transform these two fractions into two fractions with a denominator of 35. Let's do 3/5 first. What do we multiply 5 by to get to 35? We'll multiply by 7. Whatever we do in the denominator, we must do in the numerator. 7 times 3 is 21. So now we've transformed 3 over 5 into 21 over 35. So now let's do 5 over 7. What do we multiply 7 by to get 35? We'll multiply by 5. 7 times 5 is 35. Whatever we do in the denominator, we must do in the numerator. 5 times 5 is 25. So now, instead of comparing 3 over 5 and 5 over 7, we can simply compare 21 over 35 to 25 over 35. And we can easily see that 21 over 35 is less than 25 over 35, which means we can say that 3/5 is less than 5/7. There you go. Now that we know how to compare rational numbers, let's order a set of rational numbers. Now we did this earlier with integers. We simply took the negative numbers and the positive numbers and looked on the number line and see which ones come from least to greatest or greatest to least. So let's order this set of rational numbers. We have 1 over 4, we have 2 over 3, minus 1/2, we have 1/3, and we have minus 4/5. Okay, so how do we do this with integers? Well, going from least to greatest, we went from left to right on the number line and we dealt with the negative numbers first. So we have two negative numbers here that we want to deal with first. So let's start out by just dropping the negative signs and dealing with just the fractions, 1/2 and 4/5. Well, this we're going to have to do the second way that we learned to compare fractions up here. We're going to have to transform both fractions because we can't divide 2 into 5 or 5 into 2. So we're going to transform these two fractions into two fractions with a common denominator of 2 times 5, which is 10. So let's transform 1/2 first. What do we multiply 2 by to get 10? Well, we can multiply it by 5. 5 times 2 is 10. Whatever we do in the denominator, we must do in the numerator. 5 times 1 is 5. 1/2 is the same as 5/10. Just looks different. So let's do 4/5 now. What do we multiply 5 by to get 10? Well, we multiply 2. 5 times 2 is 10. Whatever we do in the denominator, we have to do in the numerator. Multiply by 2. 4 times 2 is 8. We can see from here 5/10 is less than 8/10. So from that we can conclude that 1/2 is less than 4/5. But we're not done yet. These are negatives, so let's put in our negatives. Now we saw when we were ordering integers that the greater the number is, the lesser the value is when it's negative. So if a positive 1/2 is greater than a positive 4/5, we can say that a negative 4/5 is less than a minus 1/2. Because the number 4/5 is greater than 1/2, but since they're going in the negative direction, minus 4/5 is more negative than minus 1/2. So in ordering, we're starting with the negative numbers. We're going to start with minus 4/5 and minus 1/2. We can mark these out. So now we just need to compare and order these three rational numbers. Well, 2/3 and 1/3 is actually very easy. They both already have a common denominator. And we can see that 1/3 is less than 2/3. 1 is less than 2. They both have the same denominator. So all we have left to do is figure out where 1/4 goes. Does it go before 1/3 or does it go after 2/3? So let's start off by comparing. Let's compare 1/4 and 1/3. 1/4 and 1/3. Okay. Well, this is another one that we're going to have to transform both fractions. 4 won't divide evenly into 3, neither will 3 divide evenly into 4. So let's transform these fractions into a fraction with a common denominator of 4 times 3. 4 times 3 is 12. Let's transform 1/4 first. 4 times what will get us 12? Well, 4 times 3 equals 12. So we multiply by 3 in the denominator, so we have to do the same in the numerator. 3 times 1 is 3. 1/4 becomes 3/12. Now let's do 1/3. 3 times what will get 12? 3 times 4. What we do in the denominator, we have to do in the numerator. 1 times 4 equals 4. So 1/3 is the same as 4/12, and we can compare these two and see that 3/12 is less than 4/12. By that, we can conclude that 1/4 is less than 1/3. So we know that 1/4 is less than 1/3, and we know 1/3 is less than 2/3. And since these are only positive numbers, we can actually fill in the order. Next is 1/4, then 1/3, and then 2/3. There you go. These are ordered from least to greatest. Now what did we learn here? We learned how to classify rational numbers as a proper or improper fraction. A proper fraction has a smaller numerator than the denominator. An improper fraction has a larger numerator than a denominator. We also learned that we need to put our fraction in lowest terms. That is very, very important, as we'll see later on. We also learned how to compare rational numbers. If there's a denominator that will divide evenly into the other denominator, it's much easier to transform one. If not, then we can transform both fractions and compare them that way. And thus, so we can order from least to greatest or greatest to least some rational numbers. Rational numbers are very important. They appear all through algebra, and so we need to really get this down. I'll see you soon.